the main event. Dr. Joellen Russell is the Thomas R. Brown Distinguished Chair of Integrative Science and professor at the University of Arizona in the Department of Geosciences. Joellen is the mother of 2 children, 9 and 13. Her children and students' compassion, kindness, and hard work have convinced her that when it's their turn, we'll all be in good hands. Growing up in a tiny fishing village in the Arctic, she was always fascinated by the ocean and knew she wanted to be an oceanographer at the age of 12. And she is a... That's good. You were on your career journey really early on. I feel like I still don't know where I might be tomorrow, so that's the fun part. We are so proud that she is coming to talk to us about her work with science bombs, and what we all can do about climate change and how we can turn facts into action. So I am going to hand it over to you and get out of the way. Thank you again for being here. Is your clicker?
Thank you.
Microphone?
Hey, thank you for having me. I cannot tell you how excited I was that we're having this amazing Tenwest. I hope many businesses get started, get off the ground, get big. It's completely awesome. Both my kids are born and raised here in Tucson, even though, of course, I ditched Princeton to come here, right? Because we build big things in Arizona, 1. 2, we have amazing students, the how high kind of students. I had a hard time convincing Princeton students that they didn't want to go be an investment banker. No, your math can be used for good. It can, it's awesome. So let me show you a little of what we've been doing here at the University of Arizona. And then I'm going to tell you a little bit about the nonprofit we founded during pandemic with 9 other climate scientists who happen to be moms. We felt like we needed a way to tell people about how climate science is changing, how our planet's changing, and what we can do about it in a low-key, non-threatening kind of, here's the progress we're making. So let me show you what we're doing. And I want to start here. I know you've seen this one a million times, right? It's the pale blue dot. Carl Sagan said to NASA, hey, turn around Voyager as it's leaving our solar system and tell Voyager to take a picture of home and send it back to us like a postcard. And it did. And this is that tiny little spaceship Earth hanging in our big, vasty, dark universe. And that's home for all of us, right? All of us, every book you've ever read, every person you've ever loved, right here on planet Earth. There's nothing else, right? And it's blue. When it's hanging there, it's called the pale blue dot. Why is that? Because 72% of our Earth's surface is ocean. Yeah. You're going to tell me, what? You're here in Tucson talking about oceans? I'm like, I'm not just here in Tucson talking about oceans. We're predicting our weather. We're predicting our climate. And we're using an ocean and an ocean model, robot floats, satellites, and supercomputers to get a look at our future and the changes we can make and what they will do. What's the direct impact of our choices right here in our own individual lives and the way that that is collectively changing, terraforming our planet. It's pretty exciting. So everybody looks at this one and says, wow, those satellites have been getting really good, haven't they? They've been getting awesome. That's not satellite. That's a model. That's simulation. That is a whole bunch of math and supercomputers. Yeah. Did you know that the University of Arizona, that my group at the University of Arizona is the very first university in the world ever to run the climate models that were run in support of the IPCC report that just came out last year? No university has ever managed to muster that kind of muscle in order to complete the runs that would be required to participate, and we did. It's amazing, and this is the brand new Weather Service model. Okay, the National Oceanic and Atmospheric Administration's Weather Service model used to be just an atmosphere, and now they've included an ocean. You know what that makes it? A climate model, because that's the difference. Before, when we only had an atmosphere, that was our weather model. Now, in order to do the weather, we need to know how hot the ocean is. So we've seen a convergence of this new tech Basically, we're not just an atmosphere anymore, we're an ocean. Why? Because the patterns of circulation have changed a lot and our ocean has gotten really hot, very warm. So why do we need that here in Arizona? Well, okay, you can see the increase in heat waves. Everybody's felt it, right? As a mom, I'm like, that's cabin fever season for me. I mean, if we don't get a few fewer 100-degree days where I can throw the kids outside to play, Mama's gonna need another drink. No, seriously, it's awful. So yeah, so heat waves, we've all seen it, we've all felt it, we know what that means, cabin fever, you're killing me. Not just that, but our bills, right? Who loves their AC bill in the summer? Yeah, none of ya, I know it. Okay, drought. Anybody been to Sea Lake Mead lately? It's getting scary up there. Our Colorado River water is our life's blood out here. And wow, are those bathtub rings getting serious? And you can see that here. And then of course, I want all those high-tech jobs that come with the prediction, adaptation, and information about how to do it better and save a buck while you're doing it. I want those jobs to be here, of course. So Arizona is the 3rd fastest warming state. Yeah, you knew that, right? Well, how about this one? Tucson is the 3rd fastest warming city, and our neighbors up the street there in Phoenix is number 4. Yeah, it was getting hot. You know, we broke that record a year or so ago for number of 100-degree days. We went from a record here in Tucson ever of 98 to 108. I just thought, you know, if ever to start daydreaming. No, just kidding. So here's what it looks like. It doesn't really matter where you are in Arizona. This is Yuma, Phoenix, and Tucson. It's getting warm. And here's a drought monitor picture. This is from this last spring, but that's looking pretty bad, isn't it? It's a lot of drought. All right, and here's our Lake Mead. Down, down, down. It's a worry. And we know part of the reason that it's getting hot and dry is because of this increase in atmospheric CO2. Now, there's 2 lines there. One of them, the red one, is from the South Pole. The other one is from Mauna Loa out in Hawaii. They're saying the same thing. Okay, any of you got a crazy uncle skeptic who says, it's the volcanoes? I triple dog dare you to show me where the 4 major volcanic eruptions are on this plot. You can't see them. I know you can't. I know you can't because the first derivative is the seasonal cycle, the second derivative is El Nino, and the third, teeny weeny doesn't matter, is volcanoes. El Chichón, Agong, and Pinatubo are all on here. You just can't see them because they don't matter. We've drowned them out with human emissions. Yep, that's what it is. All right, so I told you that we were adding an ocean. This is a climate model. It's when you take an atmosphere and you add an ocean and a land surface to it with all that lovely hydrology and flooding. And then, if you're really getting fancy, you add the carbon cycle. So a lot of what I'm going to show you is us doing totally awesome things with these. They are complex. They are 2 million lines of code plus. Yeah, we run them at the university's High Performance Computing Center here at the University of Arizona. Did you know our supercomputer is bigger than Stanford's? Bet you didn't know, but it is. Stanford can suck it. Don't tell them, I have friends up there, but still. And we've really changed. Once upon a time, we only needed an atmosphere, and then we added an ocean, because in order to do climate and now weather, you really have to have how hot is that ocean. And not all climate models are made the same. These are my favorites, these GFDL ones, because their uncertainties are really low. In fact, they're within the error of the observations, which is in green there. So that bottom one in the red, I don't mean, this isn't me being, I'm not picking on them, but that's the Chinese model at the bottom. And third from the bottom is the Russians. I'm just saying, not good. And here's a climate Turing test. Any of you guys good with puzzles? Because can you spot which one is the observations and which one are the climate models? Unless you're trained, I bet you can't. Only one of these is actually the observations. The rest are climate models. I'm just trying to show you, we've gotten really, really good at this. That's why they're using it for weather. So once upon a time, if the last time you thought about climate was in the 90s sometime, it wasn't that certain. It wasn't even called out in 1990 as part of the first report on global warming. But in 2013, it was 95% chance responsible. Human machines are responsible for the warming we're seeing. 95% chance. And just so you know what the loading is, this is the radiative budget, the annual greenhouse gas index, which is how much forcing for additional greenhouse gases that are scattering all that excess. So shortwave comes in from the sun, warms the surface of the earth, tries to escape back out as longwave. And if you have greenhouse gases, it doesn't let it out. And the reason we know this is ERBE, the Earth's Radiation Budget Experiment, which is a series of satellites that sits out of the edge of our atmosphere and looks out at the sun and in at the earth, and it says, this many, it's about the same every year that comes in from the sun. About the same, really doesn't change that much. But less gets out every year. And it's because of this. This is why it's less out every year. And you're like, but wait a minute, we're not hitting a record atmospheric temperature every year. So how can that be if less gets out every year? Well, so here's our global atmospheric temperature anomaly. You'll notice that not every year is a record. Most of them are, but not every year, right? And we see all these climate change indicators, whether it's ice or humidity or whatever, but you know where all that heat's going? Well, okay, it's 93% going in the ocean. Ocean heat uptake. Global warming is really ocean warming. It's 93%. So why do you need to do the weather with an ocean model included? Because it's gotten too damn hot. It's really warmed a lot, and that's causing things like the Great Barrier Reef to bleach. So if you haven't been, if you've got the means, you might consider it, because half of it bleached and only a percentage of it actually recovered. We're expecting the next El Nino to really hit it hard. And if I can't interest you in a Great Barrier Reef, it took 1 million years to build, and we're busy destroying it in a matter of years. How about Norfolk, our greatest naval base? Norfolk, under 1.5 degrees of warming, which we're gonna blow over, right? This is how much of it is under sea level. 2, most of it, and 3, all of it. This is a really big deal. These are incredibly expensive, critical infrastructure for us, and it makes a big difference. Here's how much of Seattle, if you just had 10 feet of sea level rise, this is how much of Seattle is underwater. Whoops. That's not small, is it? And here's all the critical infrastructure, either social vulnerability or actual power plants and other things that could be underwater. So it's a big deal. So now we're trying to figure out, well, okay, that carbon thing, how do we fix that? So my lab is all about carbon accounting. All about it. These are the emissions. This is just from 2016, but I love it because it says, here's what we used and where the CO2 went. How much of our energy created, and 75% of it is CO2. Some methane, some nitrous oxide, but that's really what it is. And who did it? Well, we got an estimate. Now there's some uncertainties on this, but did you know that the US is dropping their emissions faster than almost any country on Earth? Bet you didn't. You know how much we've dropped our emissions since 2007? 20%. We grew our economy, we grew our population, and we dropped our emissions by 20%. We're gonna hit our 50% emissions target well before 2050. In fact, we were supposed to make it by 2030. I know, aren't you? Isn't that wild? Everybody's like doom and gloom, oh, we can't do anything about it. I'm like, we were 20+% of global emissions. You know what we are today? 13. America is 13% of emissions, while being more than 20% of the global economy. So come on, startups, let's go. No, seriously, and on a sustained day, let's talk about how much more efficient we are. It's amazing. All right, we might hit if this new Climate Act works even half as well as everyone's talking about, there's a possibility, in fact, I think it's likely, that we're gonna hit our 50% emissions cut by 2034. That's just 12 years from now, we'll have cut our emissions in half. And that half means we'll only be 6% of the global emissions, while still being over 20% of the global economy. Everybody keeps going, oh, there's nothing we can do. I'm like, really? Because we're already doing it. Any of you have a hybrid or decided to go all electric with your car? Anybody given up your gas stove and gone induction so your baby can put their hand on it and not actually burn themselves? I cannot tell you. Gas dryer or line dry. I mean, really seriously, everybody's putting solar panels on their roofs and you didn't even notice how big an impact we'd had as a country. It's amazing. So what we're doing is we're trying to figure out how much of these emissions, now, okay, certain of our competitors, China, has been busy lying about their emissions and saying that the ocean did it. I kid you not, it makes me crazy. As an oceanographer, I'm like, no, it isn't. And they're like, prove it. I'm like, alrighty then. All right, so how do we prove it? If there's a lot of exchange and this upwelling is entirely wind-driven, so why am I having trouble with it? Well, there's this other thing. All these startups that are trying to remove carbon from the atmosphere, a lot of the marine ones will probably not work because of that upwelling, because the winds are growing. And that matters here in Tucson too. This is the wave heights in the ocean. They're wind-driven. So this is the trend over the last 30 years. Do you see very many little blue dots in there where it's decreasing? No, you don't, because the winds are increasing globally, and this is part of our global warming problem. And it's driving deeper mixing in the ocean. And we're underestimating them so badly that while I'm an oceanographer, I got into the satellite business last year and proposed that the University of Arizona to NASA, that NASA should fund the University of Arizona to put another satellite in space to do the winds over the ocean, scatterometer. We didn't win. It was close. We had no major weaknesses, but I swear I'm gonna go back and get a global one, and they better give it to me. It's gonna be great, because we'd have all these students and businesses working to give us this picture. How much is going in? This is carbon flux simulated. I would love to give you the actual data, but I can't because I don't have enough wind information to do it, but I'll get it. Don't worry. Any minute now. Give me about 4 years to launch that puppy, because going to sea is super hard. We went from just the ship measurements, which is on the top, to all of these float measurements. Now these are robot floats. They are very cool. And with my friends at Princeton and at Scripps out at UCSD, we actually got it funded to put, instead of just more ships, okay, a research ship costs $100,000 for every 2 days of ship time. My floats cost less than $100,000. Believe me, it's like pushing a Tesla off the back of the ship. It's a little scary, but they're completely awesome because they'll last 5 years. And instead of the 5 profiles I get from a ship in 2 days, I'll get 250. Micro sensors, better batteries, better automation, and plain old sneaky cleverness. Robot floats are making real-time measurements of our global ocean carbon sink. I'm not just available, but we're gonna prove it. We're gonna prove it. They're gonna say, we didn't emit all that, it was the ocean. We'll be like, ah ha ha, my float said no. So we started this back in 2014. That was when we got this, started deploying our floats. Just by the way, our first floats was deployed by a student out of my great big huge 650 person oceanography class at the University of Arizona as a sophomore. No, seriously, our students are amazing. And she was on a polar stern, which is the German icebreaker south of Cape Town, South Africa. And this actually is one of our other students, and this was just this last year. And you'll see that's the way we used to have to do it, was just with these great big fat arrays of bottles that we would pressure release, and they bring the water back up, and then we make all these samples. It's incredibly time intensive. I've spent more than a year of my life doing this at sea, mostly in the winter around Antarctica. Oh my God, I have nightmares about black water over my head. I almost got swept off the deck once, and like literally, it's just my steel toe boot got stuck in the chain on the back on the fantail. Otherwise, you wouldn't see me here. You know, you only have 3 minutes before you die, and the ship takes 15 to turn around. So you might as well just wave, if somebody falls off. But all these incredibly time-intensive measurements have been substituted. We still do them. There's Becky. Say hi, Becky. Deploying robot floats off a ship. It's so awesome. So we started with 0, and this is what we have now. I know, built right here in Arizona with friends at Princeton and other places, but still, check that out. With our kids doing the major deployments, it's amazing. And this is what our array looks like now, not just around Antarctica, but the global ocean. So China, your days of lying to us are tick, tick, tick on your last legs here. So this is what it looks like if you just wanted to see our real-time data. Now imagine that total, we have about 5 ships internationally doing the Southern Ocean. You would not see this if it were just ships. It's robot floats telling us how much oxygen is missing from all the rot and decay and how much growth there is from our floats. Ta-da! I know, you're not oohing and ahhing, but you should be because it's really cool. So, thank you. But if we have these windier winds, we're running these fabulous climate models. I said, okay, fine. We are missing these winds. What happens if I apply extra winds here? It flips the sign. Instead of the ocean taking up carbon, it starts to burp it back out. 20% change in the winds gives us an ocean that is now a source of carbon instead of a sink. I know. So we hope this doesn't happen, and we're gonna have to move quickly. We got really lucky too because the New York Times took an interest in the work we were doing and wrote this really cool interactive story with all this great graphics and all that. So you should check it out. New York Times, we were in last December. Front page above the fold in the paper was pretty awesome. And here's where you can see all the upwelling around Antarctica. This is what we're worried about with all that extra carbon that's coming back out potentially. And this is the nonprofit, Science Moms, because we want to make this accessible. I've thrown a whole bunch of cool ocean graphics and stuff, but what we really want to do is make it so that, moms in the carpool line can watch little tiny glip videos that show you what the science is and how to make it accessible. Let's see if another click does this. Oop. What's the plan to solve climate change? Science Moms present What to Do You. Hi, I'm Dr. Joellen Russell, but you can just call me Joellen. I'm an oceanographer and a mom. Here's the deal. Moms are worried about climate change, but a lot of us don't know what to do and don't feel like we can make a difference. You might find yourself thinking, how can me, one mom, possibly make an impact on one of the biggest issues facing humanity? But the answer's simple. You aren't alone. There are more than 85 million moms in America. That's over 175 times larger than the U.S. Army. And a lot of mom power means a lot of impact. Moms help women secure the right to vote and help stop child labor. They even turned Mother's Day into a national holiday, giving all moms the one thing they really want, a freaking day off. There's nothing more powerful than moms on a mission. So the Science Moms created the one thing all moms need to take action, a to-do list. First, swap. We're swapping carbon-polluting stuff for clean stuff. Next time you're in the market, swap out things like gas cars and stoves for electric ones. You can also get your actual electricity from cleaner sources. Most places have at least one clean energy provider. Second, we're sharing our concerns about climate change and what we're doing to help. Spam your feed, blow up your group chat, or even use your phone, as a phone. Because the more we talk about making changes, the more important making changes becomes. Last, but definitely not least, speak up. We're speaking up and asking our leaders how they plan to stop big polluters. Because it's time for our representatives to, represent our interests, like, our kids having a future. So yeah, that's it. That's the list. We can swap, share, speak up, or do them all. We can count on you because moms get stuff done. And even when we don't want to, we just end up doing it anyways. Check off your to-do list at sciencemoms.com. I know that's awful. We had so much fun doing this. ScienceMoms.com, check us out. And it's a resource for unbiased, straight, just the facts. And we'll point you to good resources at NASA and NOAA and places like that, but we'll also just boil it down. Here's the facts. And just remember, we're all of us that are, working, Catherine Hayhoe, all of these moms are climate scientists in their day jobs. We've got a wildfire scientist, a sea level scientist, a global ecosystem scientist. These are people who've been working for decades on these really cool, awesome things, and they just want to make it more accessible to everybody. And, what to do. We are doing it. We need to hurry up, hustle along. We can do it. So that was all I had for you today. Thank you for coming and having a nice lunch, and bear down. Woo!
Dr. Russell, I'm right here.
Yeah.
Do you want to take questions?
I'd be happy to.
Do we have any
Absolutely.
audience questions? And I'll run this mic. Oh, how lovely. I don't have to run very far.
Good afternoon. Thank you so much. That was really engaging. I am wondering, are there colleagues in your field, are there people in other fields that are, carbon is one thing. We have plastic, we have PFAS, we have all these things. And so are there other people like you tracking other issues on a global scale?
So we do, but this one, I showed you that radiative plot where the increase is really being driven by carbon dioxide, the amount of warming. So we could talk about other issues, PFAS being, poisoning our water, or plastic, which is very bad for ecosystems, but doesn't actually have a big impact on climate. So this is a climate science sort of focused group, and that's why SWAP is all about swapping carbon polluting for non-carbon polluting. The other part is that many of these things, like methane, only has a 10-year lifetime in the atmosphere, but CO2 will last every carbon molecule. And this is why every little bit counts. Here's the thing. Every carbon molecule that comes out of anybody's tailpipe anywhere in the world, 1 out of 4 will go into the ocean, 1 out of 4 will go into greening of the land plants, and 2 of them will hang out in the atmosphere for 600 to 1,000 years. Methane is 10 years. CO2 is basically forever. It's awful. Everybody's so worried about half-lives of nuclear waste, which is a tiny little thing that's really well contained, and yet we're willing to spew things into our atmosphere that are going to immediately make us warmer with no regard to the fact that 600 to 1,000 years they will be hanging out. It's appalling. It's important. And so yes, there are other things. I mean, I've done studies on, the Fukushima. It turned out the solution to pollution in the ocean is dilution. And we actually barely saw a sniff of any Fukushima-related radioactive material in the ocean along our coast. We have some nice papers published on that. But mostly I focus on carbon because it lasts the longest and because every single one of us, can have an impact on that. Every carbon molecule you don't put into the air will not be hanging around for your great-great-great-great-grandkids to deal with. We lift the load this generation. We don't wait. We don't push it off onto our great-grandkids. We do it now. We are not less determined. We are not less determined than our grandparents were. They beat Hitler, they built our nuclear power plant, our dams, etc. We are not less determined than they were. We are not. We lift now. We don't push it off. We fix this. And the US, quietly, with nobody seeming to know about it, is leading the way for the whole globe. I'm very excited about this. COP27 starts in a week. Bet you money they won't even talk about this, will they? They won't. But it's true, and it's happening right now. And it's regular folks making wise decisions for their business, for their family, for themselves, one by one. Instead of it being some kind of top-down thing, it's more like the little boats at Dunkirk. We just came one by one by one, little boat by little boat, to save the day. Here it is.
Thank you, you're fabulous. Would you...
It's the jacket.
It's personality. Would you mind commenting on the role that regenerative agriculture can play in carbon sequestration, and perhaps whether this is something that the science moms might consider adding to the swap category of swapping out non-regenerative agricultural products for regenerative ones?
Can you tell what his startup might be?
I love better ag. I come from, I grew up in a fishing village in Alaska, but when I was 10, my folks moved us to northern Montana. And I grew up also listening to the crop report, because that's everything in eastern Montana. And I think regenerative ag is one of those things. Disturbed ecosystems have the most potential for us to enhance what is taken up. It is so important. And frankly, all of our Tucson water and municipal waste disposal also has opportunities, because there are multiple steps in the ag process. Nobody likes to talk about that last one. But I am incredibly enthused about some of the amazing changes that we're seeing bubbling up. Better tech, better management. These are already disturbed ecosystems, but ones that we have a lot of control over. So here's a great way that we could contribute to the swap from carbon polluting to non-carbon polluting to potentially carbon removal. Such a cool thing. I'm a pro that. I will bring it up at our next meeting.
Any other questions? Oh, right here.
Okay, what do you think needs to be at the top of a climate agenda? Like, if you could talk to somebody and push it to the forefront, what do you think that would be for you?
For me, I am, I think I really appreciate that there are many environmental hazards and harms, but for me, because of the 600 to 1,000 year thing, I am laser focused on carbon. Carbon, to me, if I were pushing a climate agenda, it's the only thing that matters. I don't want to, okay, and here's the thing, carbon dioxide removal through ag is an exception, but generally, I would prefer that we just not burn it. That swapping to non-carbon polluting really means not burning it. Now, Arizona's in a really great position. We are. I know that sounds crazy, but we totally are. We have hydro, we have solar, we have wind, and we have nuclear. 43% of our electricity comes from a nuclear power plant with zero emissions that, by the way, is already paid for. I mean, I can't get over that. I'm like, so add another one just next door. Put all the waste in the backyard in the nuclear, in the Olympic-sized swimming pool. I know a lot of people are very hesitant about nuclear, but Arizona is a great example of where it works, providing that backbone for our air conditioning with zero emissions. Now, I'll hear you saying it's expensive, but if you sink the capital costs in and amortize them over the 50 to 100 years we might be using a nuclear power plant, I don't think it looks that expensive anymore. But that's just, I am not a nuclear power plant person, I'm simply a zero carbon person. So I love the combination in Arizona of renewables and other hydro, nuclear, et cetera. I feel like we should be using all the tools. I mean, can you imagine? I mean, Arizona is this close to hanging out its shingle and saying, first green state in the nation. We're that close, we could do it. Now, we haven't yet. We're actually only down about 17% of our emissions, but we could be first. It would be amazing. So for me, the climate agenda should really just be, personally, if I were doing it, if I were pushing something, I'd be like, why don't we have a energy investment bank that says, if you get low carbon power up and running within 5 years, we'll forgive you half your loan. Because the nation needs it. It's a high priority thing. So you build it and then we forgive your loan. If you get it done in 5 years and you're efficient and on time and in full, we want to encourage you. Move it. I just get excited to watch the private sector innovate. Yeah. I mean, we have amazing possibilities. We just need to tell them that we need their help and make it worth their while, in my opinion.
Thanks, Professor. Really engaging talk. I want to echo that sentiment other people have shared. I was curious if you could speak to the surface microlayer and the phytoplankton layer there, and your opinions on the impact and import of its carbon sequestration possibilities and the state of its health right now.
So I worry that even if, so one, nutrients are actually getting more scarce. Plant food is getting more scarce where, because the circulation in the ocean, when it gets that thick, fat layer of warm water on it, and that fat layer is getting thicker and thicker, it's harder to mix the plant food up through it. Now, at the high latitudes, at polar regions, we're seeing more mixing, right? But less where everybody else lives and where they fish. This is really scaring. So we're seeing greening in our polar latitudes, but we're seeing starvation in most of the rest of the world oceans. It's pretty scary. Now, these are trends that are messy, hard to see. Just by the way, our floats have 2 optical sensors on them. One is for the chlorophyll content of the water, and the other is for the particular organic carbon, basically the poop and dead bodies. Don't tell anybody. So we are absolutely looking at this in conjunction with satellite measurements. It's very exciting. I would love it. The problem is you have to get it really deep for it to stay, especially if the winds are blowing harder. So while it's incredibly possible, so far I'd prefer we prevent it from getting in the atmosphere. If we have to, the ocean might be a way to go. But in fact, I was just on a National Academy of Science panel talking about this, and they put me on there because I'm a little bit of a curmudgeon who goes, and then the wind blows hard and it burps it back out again. And everybody's like, oh, you're such a downer. I'm like, I'm so sorry. But I am worried about these winds. I want that satellite.
Hi, I'm Janice Siegel, and I'm the water ambassador for Sustainable Tucson.
Yay!
Thanks. But I think that you're so engaging, and my question for you is, do you have the ear of the president of the U of A, and how has Mothers for Climate Change advocated for the U of A?
Well, he's sending me to South by Southwest.
Yeah! We got a preview. This was like a sneak peek for Tenwest. We're so excited that she joined us today.
So it's I'm also, I'm going to set the sounds off. They made me a distinguished professor at the university, so we actually get to meet with him fairly often. And I am incredibly excited about the climate initiatives on campus, not just for our own sustainability and impact, right? I mean, we're chilled water, we're not like air conditioning, we're chilled water. I mean, there's all kinds of cool things that go on at the university, but also because I ditched Princeton because, like geo and water, we're ranked way higher than they are. I'm ranked highest here than I was at Harvard. I'm not joking. These guys kick every ass. I mean, excuse me. No, they do. It's awesome. I have the most amazing colleagues. They are doing the cutting edge in science on climate, on water, on arid areas, on animals, on rangelands, on ag, on hydrology. I mean, they are the shit. Yeah. So, and I feel like I know he understands how important this is. We are kind of got kicked in the teeth this fall because we lost Tom. And he and I started at almost the same time here and have been on umpty committees, written umpty proposals together, had so much fun. We miss him so much. But I feel like the university's been building momentum in this climate, water, adaptation space. And we're bringing in like the bucks. Holy, the university's research budget just keeps going up, up, up. We have to, the funding rates are like 10% at the federal level. Do you know what we have to do to outcompete Caltech? And we're doing it. Caltech, MIT, Harvard, they can suck it. We are going to beat them because we're really good at this. Also, because we live in Arizona, which is the hot seat for climate change, right? Who has friends or relatives who live out in Yuma? Who's worried? I mean, we're worried about this. We know what Lake Mead looks like. We know what the predictions are. And if we believe our own work, we need to hustle faster. It's sort of why we started the, I'm also the UA Cares co-chair with the president this year for, UA Cares is our voluntary sort of contributions to the community in money for nonprofits. And we've been pushing that this year, trying to get all of our folks and employees to do $5 a paycheck just to help the rest of the community, whether it's the diaper bank or AZPM or, you know, making sure that we're giving back to this amazing community we live in. And so I know the president knows what we're up to. He's sending us out to do the good work here, and I'll just say, I think we're winning. I think we're on the right track, and it's thanks to this is a little boats thing. This is not some big monster top-down thing. This is a wise people making wise decisions on behalf of their great-great-grandbabies that they will never meet. Thank you.
Hi, I have a quick question.
Oh, go ahead.
Sorry, if you're okay, Dr. Russell.
I'm Joellen Odell with Safety, Health, and Environmental Consulting. A quick question. First of all, you are amazing. I love listening to you. Anyhow, what do you think of hydroturbines that are, you know, built deep beneath the ocean? Do you think that those would be effective based upon your comment about being bilged back up?
I was actually quoted a couple of times in the Business Insider piece that came out 2 weeks ago about using offshore resources for wind and currents and wave action energy. I am a huge fan of all of these. I have a bunch of friends who have a test bed called PacWave out off Oregon, and this is awesome. I am thrilled. And they're doing better mapping of our offshore resources so we can manage them better. And when I say resources, I mean untouched seabed. I mean, where are our pipelines? We don't want to drag them with our anchors and everything. And our fisheries, we're doing a climate and fisheries initiative to try and get a better handle on stock takes that take climate into account. These big, because, you don't want all of our lobsters in the Gulf of Maine heading for Halifax, which is kind of happening. So it's very exciting. I'm pro. I really think there's a lot of opportunity there. And I don't understand why you can't look at a Google map of our seafloor the same way you would on land. We can do that work. We just haven't done it yet. It's a resource. It's a frontier that's just not being managed well yet and not being explored well yet. So yeah, I'm a fan. So the deep sea is very different, and particularly off our coast. I'll just say California coast is a cold current coast, and there is upwelling there, but it's seasonal, rare, and unlikely to be a problem.
Okay, we're gonna stop there. Sounds like you guys can have a follow-up conversation. Okay, big thank you for Dr. Russell for joining us today.